Welcome to Breaking Wire. Please subscribe to the channel and press the bell icon for more updates. Earlier this year, headlines screamed of a terrifying object hurtling toward Earth, sending shockwaves of fear and uncertainty across the globe. News outlets and social media platforms buzzed with speculation, and people everywhere paused to wonder if this was the moment disaster would strike. The supposed culprit? An asteroid, allegedly spotted by the powerful James Webb Space Telescope, which had only recently begun its mission to unlock the secrets of the universe. Phrases like NASA Red Alert and terrifying object detected flashed across screens, fueling public anxiety and sparking heated debates online and in living rooms everywhere. The story was gripping. A massive asteroid discovered by our most advanced telescope was on a collision course with our planet. The idea of an unstoppable force from space captured imaginations and fears alike. But as with most sensational news, the reality was far more nuanced and far less dire. Experts quickly pointed out inconsistencies, and scientists urged the public to remain calm. There was no NASA Red Alert, no panic in mission control. The professionals responsible for our planetary safety continued their work with steady hands and clear minds. Instead, scientists quietly got to work, analyzing the data, double-checking their findings, and communicating with colleagues around the world. The real story is about scientific process, international collaboration, and the tireless efforts of experts who dedicate their lives to understanding the cosmos. It's about the power of technology to turn fear into understanding, and the ability of science to separate fact from fiction. This wasn't the end of the world. It was a demonstration of how we're getting better at protecting it, using knowledge, vigilance, and cooperation. Our best defense against the unknown? Curiosity, teamwork, and a willingness to question what we see and hear. In the end, it's our relentless pursuit of knowledge and our ability to work together that truly keeps our world safe. Let's meet our celestial visitor, Asteroid 2024 YR4, a cosmic wanderer that's captured the imagination of scientists and stargazers alike. This isn't just any space rock. It's a skyscraper-sized object silently gliding through the vastness of our solar system, a reminder of the dynamic and sometimes unpredictable nature of our cosmic neighborhood. First spotted in December 2024, not by the powerful James Webb Space Telescope, but by vigilant ground-based survey telescopes, this massive asteroid immediately caught astronomers' attention. Its discovery was a testament to the global network of observatories working tirelessly to scan the skies for new and potentially hazardous objects. Its impressive size and the path it traced through space made it a near-Earth object, or NEO, that demanded close monitoring. Even a distant pass by an object of this scale can have significant implications for our planet. Early observations provided only a rough estimate of its trajectory. Like glimpsing a ball thrown across a field at dusk, you know it's there, but the details are fuzzy. Astronomers had to act quickly to gather more data before the asteroid slipped out of view. NASA's Center for Near-Earth Object Studies, or CNEOS, ran complex projections, factoring in the gravitational pull of planets, the asteroid's speed, and even the subtle effects of sunlight nudging its path over time. The first computer model showed a close approach in 2032, raising both curiosity and concern, and prompting a flurry of more detailed study and international collaboration. This was planetary defense in action: detect, estimate, and refine. Teams around the world worked together, sharing data and refining predictions to ensure we understood exactly what we were dealing with. There were no monsters lurking in the dark, just a known object and a preliminary flight plan, carefully charted by experts. The real challenge was turning that rough sketch of its orbit into a precise, reliable map, one that could tell us exactly how close this skyscraper in the sky would come to Earth. This is the essential, behind-the-scenes science that keeps our planet safe. Quiet, diligent work that stands between us and the unknown every single day. Tracking an asteroid's risk is a process of shrinking uncertainty with every new observation. Each new piece of information, no matter how small, helps scientists refine their understanding of the asteroid's path and potential threat. It's a careful dance between data and doubt, where every measurement matters. In early February 2025, as more telescopes tracked YR4, the chance of an Earth impact rose to 2.3%. This number, while seemingly low, was enough to catch the attention of experts around the world. The more eyes on the sky, the clearer the picture became. But sometimes, more data can initially make things look worse before they get better. That sounds small, but for an object this size, it's taken seriously. Even a tiny percentage can mean significant consequences when the stakes are this high. The sheer scale of the asteroid meant that even a remote possibility demanded urgent attention. This triggered a global coordinated observation campaign. Teams from different countries pooled their resources, sharing data and expertise in real time. The world's best minds united, determined to solve the puzzle as quickly as possible. Why the rising odds? Early data is limited, so predictions are broad, like guessing a car's destination after seeing it for 2 seconds. The first glimpses of YR4 were blurry and incomplete, leaving scientists to fill in the gaps with educated guesses and probability models. As more data comes in, predictions sharpen, sometimes making the risk appear to grow before it shrinks. Each new observation narrows the range of possible outcomes, but in the early days, that range can include some frightening possibilities. The 2.3% chance didn't mean disaster was likely, just that a small fraction of possible futures ended badly. It's a reminder that probability is not destiny, but a measure of uncertainty, one that can change dramatically with new evidence. Scientists raced to gather more data, knowing that clarity would come with time. Every observation, every calculation brought them closer to the truth, and the world waited anxiously for answers. This tense phase fueled the alarming headlines. News outlets seized on the uncertainty, amplifying public anxiety as scientists worked behind the scenes to resolve the unknowns. But it's a normal, critical part of planetary defense, science working under pressure to bring clarity from uncertainty. The process is designed to be cautious, to ensure that no threat goes unnoticed, even if it means enduring a period of doubt. Each new data point could change the story. The narrative shifted with every update, as scientists refined their models and narrowed the asteroid's possible paths. The world watched, as astronomers worked to reveal the truth, knowing that in the end, science would replace fear with facts. At the height of concern, the James Webb Space Telescope entered the scene, offering new hope. Webb, seeing in infrared, can spot even dark, cold asteroids with truly stunning clarity. Its precision allowed scientists to measure YR4's size and position with unprecedented accuracy and confidence. Feeding this data into orbital models dramatically refined the asteroid's predicted path and future trajectory. Thousands of potential impact scenarios were ruled out almost overnight by the new information. Webb's observations provided the definitive answer. YR4 was not on a collision course with Earth. This episode showcased the layered strategy of planetary defense: ground-based surveys, follow-up tracking, and, when needed, our most advanced space telescopes. These tools aren't just for cosmic beauty, they're practical shields for our planet's safety. With Webb's data, NASA and international partners recalculated the odds. By late February 2025, the impact probability dropped from 2.3% to just 0.28%. More observations refined the trajectory further. On March 24, 2025, NASA announced, Asteroid 2024 YR4 poses no significant threat to Earth. The risk corridor had shifted away, the headlines of doom were officially debunked. This was planetary defense working as designed: identify, monitor, and rule out threats with science and global cooperation. For at least the next century, YR4 is off the hazard list. The story became a real-world demonstration of our growing ability to protect our planet. We can look up with wonder and security, knowing the sky is not falling. Just as the Earth was cleared, Webb's data revealed a new twist. YR4's path now brought it closer to the moon. The chance of a lunar impact during the 2032 flyby rose to about 4.3%. An impact on the moon poses no danger to us. Our lunar neighbor has weathered countless collisions. A hit would create a new crater but not destabilize the moon or threaten Earth. For scientists, this is a rare, exciting opportunity, a chance to witness a major lunar impact in real time. Observing the event could reveal secrets about both the asteroid and the moon's subsurface. What began as a source of anxiety is now a must-see astronomical event. In science, every new answer opens the door to new discoveries. A possible YR4 moon collision is more than a spectacle. It's a planetary defense dress rehearsal. The International Asteroid Warning Network will coordinate to predict the impact's timing and location. Telescopes worldwide will capture every moment, testing our global response systems. The scientific payoff? Insights into asteroid composition and lunar geology, vital for future defense strategies. It's a natural experiment like NASA's L-Cross mission, but on a grander scale. The story of YR4 began with fear, but ends with hope and empowerment. We're not just passive observers, we're guardians, learners, and active participants in our cosmic neighborhood. Whether YR4 hits the moon or not, we'll be safer and smarter for having watched it come and go.